Hi, I'm Shane Leonage, and it's my pleasure to get the opportunity to present to you at the Tennis Innovation Conference number 2. The name of the presentation is Tennis 2.0 AI and Technology Hit in the Courts. Excuse the very poor pun that I've used there. And I guess the focus of the presentation is really upcoming trends in data, technology, AI that are going to not only impact tennis but impact the high performance end of tennis as well. So really, I do want to dive into in the presentation the impact to coaches, but also the impact to performance analysts, performance data scientists that play a bigger role within these teams now.
I won't spend a lot of time on this slide, but yeah, I've worked in I guess data roles for maybe the last 10-15 years in a number of industries. In the last decade, it's been a lot more in the sports space, working at a number of sports, and then yeah, started my business in 2017, and yeah, working with a number of players and federations as well. As you can see on the slide, I'm going to introduce a few technologies that I think are already having an impact in tennis, but will continue to have a significant impact, in fact a lasting impact on the game. And as I mentioned at the start of the presentation, I think it's going to make a significant difference to you know, the high performance monitoring, high performance scouting, really that top end of the game, coach education, and also the role of performance analysts within the industry. I do want to point out a couple of caveats before we sort of dive into the presentation. What I'm giving you is an intro into these technologies. By no means is a comprehensive dive into the mechanics of these technologies, and certainly if you're interested, I do encourage you to take the time to do your own independent research on them. There's some great research papers out there continually progressing in this space, and I think in the next 12-18 months to 3 years there's going to be a lot of work done continually making some of these technologies even better. The second thing I want to point out is these technologies is actually nothing new. In some way they've all been repackaged as AI. It's become a little bit more in vogue since ChatGPT cut through the mainstream. But in fact, a lot of these technologies have been around for a decade under different guises like machine learning. And we've been talking about them and using them, actually interacting with them in society already. But I think it's certainly cutting through a little bit more now. And the other thing I want to mention is I'm going to introduce these technologies individually on slides, but don't think of them as a silo. These technologies actually have linkages with each other, with other technologies are already out there. So yes, definitely not a silo, and you'll see some examples that I bring up where they actually work together quite well. So I'm going to go through computer vision, generative AI, deep reinforced learning, extended reality, so AR, VR, mixed reality, and then really try and touch on how this changes, I guess, the role of a performance analyst, what they need to be across, and I think in doing so I will touch on the changing role to a coach as well. So I'm going to play a video. It shows some ball tracking, player tracking, also providing some feedback on visuals on screen for that. It's also got a prediction model sitting in the background showing, I guess, the shot quality for specific shots from different parts of the court for each player. There's also a look at the facial features and perception scores in some analysis happening in the background using some of the real-time data. It's got data coming in from a temperature feed with wind, temperature, humidity. It's also reading the scoreboard, on-screen scoreboard, to provide some statistics. So a lot of what you just saw on the screen there is captured through computer vision technology, or computer vision technology working alongside other sort of data feeds that have come in to produce that output that we saw on screen there. So what is computer vision? If you strip it back, it's really the field of work that's giving computers the ability to see and understand the world, similar to how humans see, perceive, and understand the world with their eyes. So what it involves is it involves teaching a computer to make sense of videos or images, and in doing so the the computer recognizes objects, people in objects. It can even work out emotions from pictures and images, and as well as identify what's a cat, what's a dog, what's a car, and so the ability to classify objects within images and videos as well. Now, the mechanics of a computer vision project, they can be quite different. And what I mean by this, and I might use a tennis example to illustrate this. So in tennis, you're tracking a number of things. You could be tracking a player, so maybe the player at the near end, and that can have a different model to tracking the player at the far end. Now, that can be an entirely different model, which is looking at the skeleton, the stroke mechanics, to classify whether it's a forehand or backhand. You could have a completely different model tracking the ball, or classifying the ball, or working out when the ball crosses the net, or how high the ball is, the clearance. You could have something entirely different calculating or estimating the speed and the spin of the ball. Now, it might be video that contains a scoreboard, a broadcast scoreboard, so you might want a model to capture the data from the scoreboard. There's a lot of different ways computer vision can be applied in tennis, but I do want to stress that it's not necessarily one tracking system or one thing that's working, but collectively many things, many models could be working in unison to capture data, and for this specific presentation, the AI sort of ball tracking and tagging, it could be many models working concurrently to provide that information. So why is this important? Well, coaches and players traditionally have had to rely on someone manually tagging video to get that information. So let's just play this back in an example. Let's say the player you're working with is playing an opponent. John Smith is playing Joe Ingles. Joe Ingles, you would have to source some video from Joe Ingles, and then someone in the team, whether it's a coach or an analyst in the team, would manually tag relevant moments in that video, capture some of the data, where the balls are landing, where they're serving, and then produce some sort of report and video highlight reel for the coach to view and show the player before they play Joe Ingles. Okay, so that could take a significant amount of time because someone is manually tagging each point. With computer vision, potentially the processing will be faster, so it's happening quicker than what someone would manually tag the match, and also many matches could be concurrently tagged at the same time. So you, instead of just one video being done by one person, you could have 5, 10, 15 videos concurrently processing and data being captured from that. Why is that important? Well, the sample size of the data that you're working with is much higher, and you may find different bits of footage that are relevant for the matchup from a number of matches than just looking at one specific match. So that's one of the benefits. The other benefit, which I mentioned on the screen, is you can actually come up with some bespoke statistics that are derived from the computer vision data that you're capturing almost in real time. So what do I mean by this? Let's say you're working with a player that's very good counter puncher. They like to move the ball, use the pace of the ball of the opponent, and win points that way. So you might have statistics or KPIs that you build on top of the data collected that show how often they neutralize a shot, or they go from a neutral position in the court to an attacking position, or their sprint efforts, or how many direction changes that they do at a certain incoming and outgoing velocity. So that may be the KPIs that you're looking at for a player like that. Alternatively, you might have a player that's a big serving player that's wins majority of their points early in the rally, or with a first strike style type of player, and the KPIs for them could be something like unreturned serves, or could be like, you know, how many times they get a +1 ball in a certain location, or how many times they move on the serve they move the opponent off the court, or how many times, you know, they're making their opponent move you know, more than 5 meters on the +1. So again, the data you know, sitting behind those you know, KPIs could be captured through computer vision, and then those KPIs could be displayed in real time for a coach to have a look at. And I will touch on this a little bit later when we talk about extended reality, but there's definitely an opportunity to get this in player boxes, or in the hands of coaches, quite you know, as the match is going on, just because they can in real time get a sense of how their player is tracking according to the strategy that they've set for that matchup. This is just an example of, I guess, how you can visualize some data captured through these tracking systems through computer vision technology. I'm just going to show like a really quick example where this is post a match. We've got some data of a specific player, and through I guess the AI, we've got, you know, information around where they're making contact with the ball. We're looking at a serve example here, so where they're you know, throwing the ball toss, how high it's getting, where they're making contact with the ball toss, where I guess the centroid of their body is when they're making impact. Going further, just looking at the clearance, the net clearance they get, and also looking at, you know, where the ball bounces, and finally having a look at where the opponents are making contact with their serve. So yeah, just as a way that you can, you know, capture some of this data, visualize it in a meaningful manner, get some summary statistics and KPIs on certain parts of that. But yeah, definitely something that where you're able to capture more data through computer vision, you're able to get a bigger data set to be able to do this in a meaningful way and analyze a little bit better. I do want to point out, traditionally when you're tagging, it's very hard to get that perspective around that in 3 dimensions. The z-axis, so the height was something, the net clearance was something that was really tricky for a human to tag. With some of the computer vision tools out there now, it's certainly you know, a lot easier to do, and certainly when there's multiple cameras and you're using this technology, getting the clearance over the net and the height of the net is certainly much easier to do. So the next technology, generative AI, seems to be definitely in vogue at the moment. We've all probably seen, used, heard of ChatGPT, but I want to stress generative AI is so much more than that. That's just touching the surface in terms of what ChatGPT does. I think there's so many more applications that are exciting, in my opinion. So I'm going to show you a bit of an example first before diving into what it is. So this is something we've done at DDSA, where you know, traditionally we've had some static reports, PDF reports that coaches and players would get. So what we've built is a chatbot where it reads in the static report. So all the visuals, you know, the heat maps and the statistics on the report and some of the narrative in the report. It reads it in, collects the metadata from that report, or generates some metadata for it. So it's using a little bit of computer vision as well, because there's some visual information that gets collected. And it combines it with our database, where we've got a lot of qualitative information about trends in the game, about other players, about strategy in tennis, as well as you know, data that we've collected on a range of players. So this report gets read in, and basically the chatbot then interprets what's in the report and provides responses based on that report, and based on I guess the language model that we've trained, containing a lot of tennis information, as well as just sort of grammar that we've trained it to be able to handle as well. So I'll show you some examples. So just let it load. So it can be you know, something quite simple. The user can just ask, okay, how many matches is this report based on? And on the report, and you might not be able to see it unfortunately on the screen, it actually tells you in the report how many matches or what the data set sample size is in the match. So a user can just simply ask a question like that if they don't want to go and look for it on a page, and the chatbot will give you a simple response where it's basically reading information from the report and providing it to you quickly. Or it could be a little bit more sophisticated, so where you're actually asking, so in this question we're asking for, based on the results of the page, what are the opportunities for the player? So this is tapping into the other data we've got and then providing a response based on the information in the report, the qualitative information we've already got in our data set, and then providing a response on how to interpret the data and make some use of it. So I'd say there's still a fair bit of work. This is very much in testing for us at DDSA, but it's definitely some exciting opportunities using sort of chatbots with some of the players and coaches that we're working with. Okay, so let's take a step back. What is generative AI? Again, if I strip it back, it's really like a creative computer that learns from existing examples. It could be a lot of different examples from different data sets and different mediums like images, text, video, but it learns from that and then it creates new content. So not copies existing content, it creates its own content based on what it's learned. Usually it's through a prompt, so it's some sort of natural language where a user can ask it a question or ask for certain things. But the prompt could actually be a prompt, using text, or it could be you could insert an image and say, to this image, can we change X, Y, and Z? Or a video of the same sort. So some sort of prompt, and then the computer processes that information, and based on what it's existing information it's learned, it will create some new content from scratch. So how does it do it? Well, I think I touched on before. There's existing data that it uses, range of data sources. If we put this in a tennis context, it's like a junior coach who studies under a senior coach. They learn from the drills, they learn from tennis manuals, various courses that they've got to get accreditation for. They might be working with a lot of different athletes. They'll learn from them, and they might have to deal with parents. They learn from those interactions. So they learn the patterns, the styles, the rules, the information, how different people communicate, and then at some stage they've learned enough and they're able to come up with their own creation. So they might create a new drill, they might create a new coaching manual style, and that's basically what generative is, and that's what just generative AI, the creativity of a computer, that this is about. So the content being generated doesn't have to just be text. It can be an image that you ask to get generated, audio or video. I think I'll touch on some of the benefits soon, but yeah, there's instant feedback for coaches, and a way to provide some context to data. I touched on in the example that we're doing at DDSA, where it's actually working with computer vision, where computer vision's capturing certain data and getting metadata for which is in a database, and then the generative AI is using that information to create content. Definitely there's some opportunities to enhance training and performance analysis, and I'll try and touch on that in the next slide. So what are the opportunities in tennis? You saw one of the examples, creating the chatbot, helping sort of interpret those tennis reports and answer tennis questions. I'm going to list a few more here, but I really want to stress that this list is not exhaustive at all. There will be creative solutions that people's imaginations are going to bring to life. It's almost certainly going to impact all aspects of professional tennis, from not just the performance analysis that I'm talking a bit more about, but in terms of biomechanics, in terms of recovery, in terms of sleep management, diet, so forth. All parts of tennis. I think there'll be creative people that are able to use this technology to bring and create efficiencies in the processes by using generative AI. I talked about chatbots, so I'm going to skip over that. But one of the cool things that this technology can help with is developing customized and personalized training plans based on an individual athlete's characteristics. So their strengths, weaknesses, opportunities, specific goals that they may have set, the schedule that they are planning on playing for the season, or the off-court stuff that they're doing. These programs can adapt and evolve based on how an athlete's going as well. So definitely an opportunity to use it for that. You could use it for simulation or creating scenarios to do certain drills. So an example of that could be let's say a player is struggling against a particular type of opponent. Based on the data that they've got, a drill could be created that a player and their coach can practice or simulate over and over again, so they can come up with a better solution when they're playing that particular opponent. So that's one way you can use it. Performance visualization. So I think I mentioned in the previous slide that the information generated doesn't necessarily have to be text. You can have an image. So you could have AI generate certain images based on information that will help. It could be it could help in a number of situations. I'll use the example of you may have data on a particular serve pattern of an opponent, so the AI can generate a pattern of serves that may work best at deuce or may work best in a tiebreak. So it can develop visualizations based on the information that could be useful. Video analysis and highlight reel generation. So let's say you've got a lot of video. The generative AI can help pick out relevant moments in those videos, so forehands, backhands down the line, or unforced errors when a player is hit a drop shot or something like that. It can do that. But I reckon the really cool aspect that I'm hanging out for or waiting to see some work or someone take it into that space is creating completely new video content based on prompts or information. So what do I mean by that? Let's say you want to visualize your player hitting a forehand up the line and then approaching to the net, and you might not have any of that footage in your archive, but through generative AI they'll use your player, the stroke and biomechanics of your player and how they move and hit the ball, and they'll create a completely new video showing that player executing that pattern of play, and that could be really important in helping show your athlete or get them to visualize a strategy that they may never have played before. So I'm really thinking there's some opportunities in that space, and hoping someone takes the technology to be able to do that, and I'm confident they will. The next technology I'm going to go over is deep reinforced learning. In my opinion, and in a lot of respects, reinforced learning is considered true AI. And what I mean by that is the computer is actually learning on its own through trial and error in an environment. Before I sort of go in and touch on how it has an impact for tennis, I just want to touch on a notable example, and perhaps the first example that brought sort of reinforced learning into mainstream and into the living rooms of people was in relation to AlphaGo, and there's a really good documentary. I think it's on Netflix, might also be available on YouTube. But it's basically DeepMind. Since then have been taken, I think, over by Google, but DeepMind developed an AI that was able to play the board game Go and compete, and not only compete but beat some of the best humans at this game. So I'm going to play an example from that video.
AlphaGo said there was a 1 in 10,000 probability that move 37 would have been played by a human player. So it knew that this was an extremely unlikely move. It went beyond its human guide, and it came up with something new and creative and different.
I want to see Lee Sedol when he sees this move.
He's back. Lee is back.
알파고는 기실은 뭐 확률적 계산을 하고 그냥 이기기 위한 그런 머신에 불과하다고 생각을 했었는데 그 수를 보는 순간 아니구나. 충분히 알파고도 창의적이다. 정말 아름답고 바둑의 그런 아름다움을 잘 표현한 수고 굉장히 창의적인 수였다.
This move is very special because with this move, all the stone played before is work together. It's connect. It looks like a network, link everywhere. It's very special.
So yeah, in that video they talk about Move 37 or Move 37 Magic as it's known as well. So the move happened against against one of the best players in the world at the time, Lee Sedol. It was magic for several reasons. Firstly, it changes the dynamic of that match. Ends up, in a lot of opinion, turning the match in the favour of AlphaGo, and eventually AlphaGo goes on and wins it. So it's great in that respect. But it's also a very innovative and unconventional move. So based on how humans were playing the game, and I guess the historical data that maybe AlphaGo was built around, none of that conventional sort of wisdom would have dictated that move being played at that point in time. So AlphaGo's come up with that creatively on its own. So that it's innovative and quite exciting, I think, as you saw from the reactions of some of the people involved in the project. Secondly, it actually showed some really long-term sort of strategic thinking and understanding of the game. So the move itself in the short term may not have been maybe the best move, but in the long run it would unlock different parts of the board, which would provide a huge advantage. And going back to tennis, I always think of the I think it's a funny quote from Andy Roddick, and I think it was on Twitter. He put in relation to Novak Djokovic, first he takes your legs, and then he takes your soul. And this is in reference to Novak Djokovic, I think, at the start of matches maybe losing some points to some particular players, maybe even losing a set. But the work he was doing, or what he was setting up in the start of the match, would pay dividends later in the match, and he would inevitably finish stronger than all his opponents. So in a way, I always think of that when I think of this particular move, because it may not have been short term the best move there, and in fact a lot of people that were watching it thought AlphaGo had actually made a significant error, but in actual fact it was really thinking a number of steps ahead to get the ultimate goal of winning the match. So that was really cool, and it was subtle and brilliant. That as I said, a lot of people didn't understand what had happened. Funnily enough, Lee Sedol, when he came back, and I don't know if you can gauge from the reaction of the video, but he was stunned, and he immediately knew that it was something quite special and creative. So he was one that knew, okay, this is something I didn't expect, and he kind of knew something was going on, and later on in the match he would lose. So it just really shows, I guess, the creative opportunity that is available to us with a technology like this to be able to take certain things forward in tennis as well. And I'm going to touch on that in the next couple of slides. So deep reinforced learning really combines deep learning and reinforced learning. And to explain it, I might give a really crude example. Let's say you're teaching a player to hit a forehand up the line. You reward the player when they hit the forehand up the line at a level that you deem good enough, and you don't reward them when they don't hit it at that level. So over time, the player is going to learn from the mistakes that they're making and learn from the successes they're having. In a nutshell, that's deep reinforced learning. Learning from mistakes in an environment, trial and error, and eventually finding an optimal way to continually get a reward. So deep learning is really a subset of machine learning that focuses on neural networks, so multiple layers, hence the deep. And you see in that diagram, there's a lot of layers before, separating that first input to the final output. More complex models that can deal with, I guess, non-linear data and lots of complex data better. And really, it's actually inspired by the human brains, the neural networks in the human brains, hence the name neural networks. Second one, reinforced learning. It's basically an agent. They take an action. They're learning from their environment. They'll make decisions based on the rewards that they get, and eventually they'll want to maximize the rewards. And basically combining, into deep reinforced learning, it does the reinforced learning, uses deep learning to make those decisions better to maximize those rewards faster. So I'm going to try and bring this back to tennis again and explain deep reinforced learning. And I'm going to try and use an example of some research that I did at university on optimal shot chain sequences based on court position, based on opponent type for different player types. I didn't end up going down the deep reinforced learning route as part of that work. I do mention it in the paper that I wrote, but certainly would have been an interesting rabbit hole to have gone down, and certainly something I think that deep reinforced learning would have helped get an answer to as well. So, firstly, the agent. So the agent's the entity that learns to make decisions from the environment. So in my example, it would have been a virtual representation of the player. So the digital entity version of the player that's learning from the various shots that they're about to hit. The environment in the context is really, I guess, the rules of tennis, the dimensions of the court, the physics of Earth, gravity, the weather conditions, all representations like that which the agent would learn from. So you want to make that environment as realistic as possible, because then the the analysis or the various learnings for the agent will be realistic. Then you've got the state. So the state's actually the representation of the current situation for the agent. So that could be the ball quality of the opponent, so the spin and the speed of the opponent's ball. It could be the court position for the player in relation to the net, or in relation to where the opponent is, or in relation to the lines. Could be I think speed, spin. I mentioned the ball. It could be the conditions at the time. There might be wind. So all of that is the state. The action is the choice made by the agent in terms of how they interact with the environment. So in my example, it's the decision around the shot to hit, the shot chain to hit. And the reward could be multiple things. It could be the point being won, could be a reward. It could be an improvement into court position, that could be a reward. It could be forcing the opponent into a worse position is a reward. There could be a reward around the fatigue put on the opponent. Could even be penalties as well. So basically the reward is what the agent will use to evaluate if their decision was good or bad. So ultimately, in this example, we would have the virtual entity learning from the various shot chains they're hitting, and over time they'll know, based on the state they're in, the best options available to them, and they'll try and get to or maximize the rewards that they get in the most optimal manner. And really, I think when we're thinking about deep reinforced learning, it's around setting what that goal state is. So is the goal to fatigue the opponent? Is the goal to win the match as quickly as possible? Is the goal to improve the player's forehand, or the ability to hit forehand inside out followed by forehand line? So I think what you're setting as the overall goal becomes really important in a deep reinforced learning projects. So what are the potential applications? Well, I think the optimal strategy and tactic development, something that you can use. So you could even have that live in a player box, and deep reinforced learning solution is coming up with different strategies for a coach to potentially communicate to the player. You could, in training, create some what if scenarios or training simulations which an athlete can practice to try and get ready for competition on a match day. An example which I haven't sort of touched on, but it could be really interesting, is sort of technique evaluation. And there's some really good research papers out there that looked at reinforced learning being used for an agent to learn how to walk without telling it how to walk. The agent learned from the environment the way to walk and the way to run, and basically learned, I guess, the most optimal way to do that. And I think there was another really good example about high jump, where using reinforced learning, the agent actually learned the Fosbury flop, which is the current sort of method on performing the high jump. It actually learned how to do that on its own. So certainly there might be an opportunity to look at strokes and technique under pressure situations. different ways to hit the ball, or different ways to to adapt to situations could be a potential application for deep reinforced learning. And I think combined with robotics could actually help develop really cool training aids. So you might have a ball machine that's even more capable of providing ball feeds that replicate a specific player. So let's say you want a ball feed machine to hit the ball like Rafa. You could potentially have a training aid developed like that using deep reinforced learning, so to mimic sort of certain behaviours and characteristics of an opponent. So definitely some cool application for reinforced learning combined with robotics as well. So extended reality, really, it's an umbrella term for three related but different sort of groups of sub-technologies or immersive technologies relating to it. All of them have some sort of interaction, either fully or semi-fully, with a virtual world, and mixed reality is obviously both. If I go on to define it a little bit more, virtual reality is a technology that creates a completely computer-generated or immersive technology that's not, I guess, in the real world. So that example that I presented earlier in the presentation, where you could see the contact of the ball, clearance over the net, where the ball bounces, opponent's contact, that was actually in a virtual environment. So that's an example. Augmented reality, it overlays digital information or objects into a real world. So a user can look at the real world physically, but they would have some information on it. So you might have, let's say, in a tennis context, you might be watching a tennis match and you might get the speed and spin data are being overlaid on top of that. So that's an example of augmented reality. And mixed reality is a technology that combines elements of both VR and AR, and it really just allows that interaction between the virtual objects and the physical environment in real time or next to real time. So what are the potential applications in tennis? Well, as you see, that real-time feedback for players could be something very interesting. So the example that I think is really cool is in training, a player might have hardware, glasses, could be something along those lines that a player's wearing during a match, and they're able to get feedback on their shots. So a coach may have a drill where they're supposed to hit a specific target or supposed to do certain things on their stroke or their movement, and they can get some real-time feedback. So I think that's one of the cool applications. You could potentially have a coach in a player's box that's wearing one of these glasses, and they have data on specific KPIs for the player. I think I touched on earlier in the slide that you might have a player that's a counterpuncher, and for that player you might want to visualize those KPIs, or the coach may want to visualize that whilst watching the actual match, so they don't have to look away, look at a tablet, look at another device, rather that they're watching the match and they're getting those KPIs in next to real time. Obviously there's some great applications in training and that coach experience that I mentioned, but you could actually use this as a simulation tool. So you may have a specific opponent that you're versing at the other end, or that you need to prepare for, and these tools can actually to provide a realistic environment where they're playing, and using glasses and using maybe a handheld device. A player can simulate actually playing this opponent based on their strategies, their characteristics, their ball quality, and I know there's a lot of companies that are actually doing this technology, and I don't want to name drop here in this forum, but there's certainly some really innovative work being done in this space, and it's already providing benefits to training, and I think it's not going to be too far from providing an opportunity for players to be able to prepare for opponents by going into these training environments and simulating a match against specific opponents. Furthermore, these tools can be as I touched on, coaching aids, but use it like, let's say, a virtual environment to analyze shots from different angles. You saw that example with the serve. You can have a look at the serve from bird's eye view, from the side on, from back. Certainly can provide feedback on not just matches but practice sessions as well. So combining this potentially with the computer vision technology, you can certainly get some feedback on practice sessions. And I think extended reality will be a really, really important tool for the next generation coaches. So to be able to get those coaches for not just seeing video, which they're looking at necessarily in the eyes, and not able to get every single angle. You might be able to use some of the data visualized in one of these 3D environments, and a high performance coach can really have a look at, okay, the ball quality was really good because it cleared the net like this, but off the surface it bounced like this, and it actually had some side spin, and they're able to have a look at the ball and the player positioning from a number of different angles, and it will be a really great education tool for the next coaches, in my opinion. So how does this all fit in terms of impacts? Well, I've titled this slide Performance Analyst 2.0, the changing role. I want to stress the role has already changed. It's changed over a number of years, but I think it's accelerated in the last couple of years based on my experience, and part of that has been, the trigger for me has been the relaxing of the coaching rules, or the ability for players to now communicate a little bit more with the coach. What it means is the coaches now are wanting more information in real time in the players box, and as a result, the role of the analysts, whether they're doing that work remotely or whether they're in the players box, is to now be able to grab some more information in real time and give it to the coach so they can communicate accurately to the player. The role's also changed, I think, in terms of training. So there's more devices that have been approved by ITF, devices that are used in training, some really cool technology that's come out that's monitoring everything. So I guess a performance analyst needs to be across all of that, needs to be across all of that, all the various systems, the athlete management systems, just so that they're able to ease that sort of technological burden on a coach. It's not just training, it's match preparation and in match, and I think I touched on those examples before. All of the technology that I introduced before will influence this role, and I'm not saying a performance analyst needs to be go and get a master's qualification in deep learning, or needs to do a PhD on reinforced learning. That's not what I'm saying, but I think the role itself needs to be aware of these technologies, needs to be aware of what these technologies can do and the influence to the role, and also creatively think how they can use these technologies. And it may mean you need to bring in someone into your team that is the subject matter expert and can do the the grunt work or the technical work behind it, but a performance analyst needs to be aware of what's out there. You're going to see more and more performance analysts traveling with players to tournaments, and certainly more player box duties. I can attest to that, working with a number of players. I think what's required of me and of the various performance analysts in my team in player box, I can say the duties are significantly higher on match day than they were. And I think the role's actually aligning with other sports. So you're seeing like the role of analysts in football, in NBA, in baseball, and I think the role of the tennis analyst is now not akin, but it's certainly heading in that same trajectory or same direction as those sports as well. So yeah, as I said, there's a lot more tools and sensors and devices and software out there for a performance analyst to get across. But just giving a little bit of an example of what performance analysts in my team are having to get across. That there's a mobile app that provides access to them to player data. They're able to search all the different opponents there, get some information on their recent results, their serve direction statistics, their behaviors under pressure. So the app itself can dive into some physical characteristics, also links to video. So there's tools like that I'm sure there's some similar tools out there provided by different federations, by different the tours, the ATP and the WTA, but they're tools that are performance analyst needs to have in their back pocket to be able to do their job better. I showed a little bit of an example of some of the work that we do in DDSA Tracks, our visualizer. But yeah, these tools can provide support sort of that a different angle or the 3D look at a particular stroke or the biomechanics of a stroke. And again, that's not necessarily all the role of the performance analyst. Like you might bring in a biomechanist into the team to provide or support the analysis, but certainly these are tools that performance analyst needs to know or be across. The live data into players box, so we've got something called DDSA Live. Again, something like that at tournaments where you're getting live data, particularly with the increased interaction of the coach and the player, is important. Just a general sort of dashboard suite. So these may be, whether it's Tableau, Power BI, whether it's something a D3 sort of solution, Java script, but having dashboards that help you bring a number of different data sets together and visualize. Again, something that the performance analyst doesn't necessarily need to build themselves, but needs to be able to certainly use and maybe make some edits, and something like note capture. So to get them to be able to capture information or notes in a way during a match which can then feed into the other data sets. So all of these are just examples of tools that a performance analyst needs to be across in this sort of modern wave or modern way that they're required to do their role in tennis now. Yeah, so I think to dive into this further, so the new apps and tools are important. The sensors are the other thing. So we saw Whoop sort of hit the markets a number of years ago and provide some good sleep data. You've got Catapult devices. You've got a lot of other different foot sensors, force plates. So to be able to understand the tools out there and marry that up to a specific purpose. Work with the physios in your team, work with the sports scientists as well. So that linkage, I think the performance analyst has a greater role in providing that linkage between player and the various support staffs, particularly in the use of software and technology and data and hardware. I think the increased role of a performance analyst, they do need to have better programming skills, so coding in R, Python. There's new languages like Rust, which I think are going to become more in the mainstream. I think that's going to be important for a performance analyst to have that skill set. Data visualization, so the ability to take some of the complex data and visualize it for a non-technical audience. It's a valuable skill set. So certainly being able to do some of that in R, whether it's Shiny or using data visualization tools like Tableau, Power BI, I think that's going to be really important. More and more technology is being approved, so I think that not only to know how to use it, just to know what's being approved and what it's been approved for and the tests that have been conducted. I think that will give you an idea of what you can and you can't use it for. And then I think really think strategically in terms of partnerships, so third parties that are providing support. I think naturally you might not be able to do everything yourself, so to be able to partner with companies or third parties that are able to support, I think is important. But again, I think the performance analyst has a role in getting that support or communicating that support is required. So the impact of the coach is arguably the most significant with a lot of this technology. And I think it has a really positive influence in that it can open up a coach's time to do a lot more things in terms of coaching the player, because he's got a lot of tools that will complement the work he's doing. So you could have that sort of 3D environment to show a player certain situations in a number of different angles. You can use generative AI to generate certain images or video that will inspire the player to play in a particular way. You can use, you know, deep reinforced learning to come up with strategies, and then you can spend the time on the practice court implementing those strategies with the player and helping them execute that. So certainly some really cool benefits to coaches as well. Like with everything, it'll be the ones that are more open to, you know, being a little bit more uncomfortable. They're the ones that will arguably adapt the best to this changing landscape in the technology sense anyway. So I don't want to leave you with this. I know AI gets a bad rap about everyone, you know, potentially losing their jobs, but I actually think that this quote is funny, but I also believe in the quote. I don't know who to credit because I can't remember where I saw it, and I don't think I saw it attributed to anyone, but it sort of reads, AI won't take your job, but someone using AI will. Thank you again for allowing me to present. There's some of my details. You can find Data Driven Sports Analytics on a number of the social channels.